Hello folks, the BFIT team is back again with another demonstration to help you with more fundamental aspects of circuits. In the previous video of this series, we demonstrated the fundamentals of breadboards along with series and parallel circuit connections. This time, we will show you how to perform voltage and current measurements in circuits built on the breadboard. These measurement processes can be applied to any circuit that you build in the lab. So let's start with voltage measurement procedure. Voltages are measured at a point in the circuit or in parallel with a component. To measure voltages, we will need a digital multimeter or DMM. However, as a first step, the DMM has to be set to the proper measurement mode. Most DMMs have the capability to measure current, voltage, resistance, capacitance, and diode voltage. We will set the DMM to DC voltage measurement mode for the first part of this demonstration. As you can see in this picture, the DMM has 3 ports for connecting leads or wires. One of these ports is used for voltage, resistance, or milliampere level current measurements. One of the 2 remaining ports is used to measure currents greater than the milliampere range. The third port is connected to the ground in order to safely complete a closed circuit connection. This ground port will be used as a common port for all types of measurements. Voltage measurements are performed using 2 leads, one connected to the positive or voltage port, and the other connected to the negative or ground port. We have now completed the basic setup of a DMM for voltage measurement. Your DMM is now ready to measure voltage at any point in the circuit. It is important to note that voltage measurements are typically of 2 types, single point and 2-point voltage measurements. There is a minor difference between these 2 scenarios in the process of connecting the leads to the circuit. Single point voltage refers to the voltage at a single point or junction in the circuit and is denoted by Vx, where X stands for the name or label of that node or junction. For example, in this figure, the voltage at point A is denoted by VA. In the case of the single point voltage measurements, the positive lead of the DMM should be connected to the point or junction of interest, i.e. A, and the negative lead should be connected to the ground of the circuit on the breadboard. 2-point voltage refers to the voltage between any 2 chosen points in the circuit. These voltages are denoted by Vxy, where X stands for the name of the first node or junction, and Y stands for the second node or junction. For example, in this circuit, the voltage between nodes A and B is represented by VAB. In this case, the positive lead of the DMM is connected to the first node or junction, i.e. A, and the negative lead should be connected to the second node or junction, i.e. B. In this simulated circuit, the DMM is set to measure a voltage drop across resistor R1, which is located between nodes A and B. Now, let's see how to perform these measurements in a circuit on the breadboard. The first step is to identify the nodes. As shown in our circuit diagram, there are several nodes in this circuit. We will use our preset DMM under voltage measurement mode to measure the voltage at some of the nodes. For example, the single point voltage at node A can be measured by connecting the positive lead of the DMM to the junction between power supply and resistor R1 and connecting the negative lead to the ground of the circuit. In this case, the DMM is showing that the voltage at node A is 12 volts. While keeping the negative lead of the DMM at ground, let us move the positive lead to another node, say C. The DMM is now showing the voltage at node D as 6.64 volts. Make sure to always check these numbers with your calculations. In this manner, the single point voltage measurements could be performed in any circuit. To perform a 2-point voltage measurement, let's choose points A and B. The rule is that the positive lead of the DMM should be connected to the first node and the negative lead to the second node. So let's connect the positive lead to node A and the negative lead to node B. In this case, the DMM should show a voltage drop of 4.7 volts across resistor R1. And there you have it. That's how voltage measurements at various points in the circuit are performed. In order to perform current measurements in any part of this circuit, we will set the DMM to ammeter mode by connecting the positive lead to the current port. The negative lead should be left connected to the ground or COM port. Current measurements are always made in series with the component of interest. For example, to measure current in resistor R1, the DMM should be connected in series with R1. In order to connect the DMM in series with a component, an open circuit should be created at the point of interest. This open circuit results in 2 open ends, which will be used to connect the positive and negative leads of the ammeter. The DMM can be inserted into the circuit before or after R1. The measurement should give you the same result. In a similar manner, the DMM can be used in ammeter mode to measure current in resistors R2, R3, or R4. Once again, the procedure is to create an open circuit before or after the component and insert the ammeter between the two wires of the open circuit. Now that you know how to perform voltage and current measurements, feel free to explore various circuits in the lab.